Okay, 2018, higher level question 7. We'll have a look at the question and we'll see what's been asked. The main entrance to a door to a 2-story dwelling house is a high performing insulated wooden door with vertical sheeting on both sides. The door frame is thermally broken and is fitted in a 450mm external concrete block with a full filled insulated cavity. The external wall supports the first floor joist as shown in the accompanying outline drawing. The first floor is a 25mm floating wooden floor on a 25mm plywood deck on 200mm by 40mm wooden joists with a plasterboard ceiling beneath. To a scale of 1 to 5, draw a vertical section through a portion of the external wall, door frame, door, first floor joist and floor. Show typical construction details from a level 400mm below the top of the door to a level 300mm above the first floor joists. Show clearly on your drawing best practice design detail to ensure air tightness at the junction of the external wall and first floor. So we'll worry about part B later. Basically what we have is external concrete wall, not timber frame, it's external concrete. We have a door here, we must show 400mm of that door, and we have some joists butting into that wall that we must show the detailing of how that's done. On top of the joist we've got plywood decking first, and then we have a wooden floor on top of it, and underneath it there's plasterboard. So we have looked at a detail like this before, but it was with a timber frame construction, so we need to make a few adjustments to it. The main entrance to a door to a 2-story dwelling house is a high performing insulated wooden door. Okay, so an insulated wooden door is basically the high performing door we've drawn several times. Vertical sheeting on both sides, grand. The door frame is thermally broken and is fitted in a 450mm external concrete block wall, so a very big cavity wall that will be 100mm on one side and for external leaf, 100mm for internal leaf, and then 250mm for a cavity, so very big cavity. Full fill insulated cavity also. The external wall supports the first floor joist as shown in the accompanying outline drawing. So there's the external wall, there's the joist. We need to show how this is done. The first floor is a 25mm floating wooden floor. A floating wooden floor is just a wooden floor. Alright, that can be a bit off-putting. So it's just timber flooring is put down upstairs on 20mm plywood decking. So what's happened is they put down sheets of plywood on the joist first, and then they put down the wooden floorboards on top of the plywood on 200 by 40mm wooden joists. So these joists are 200mm that way, with plasterboard underneath. So there's plasterboard underneath there. Some of that information can be a bit off-putting, but when you break it down, it's quite straightforward. To a scale of 1 to 5, draw a vertical section to a portion of the external wall, door frame, first floor joist and floor. Show typical construction details 400mm below the top of the door to a level 300mm above the first floor joist. So we must go 400mm below here and 300mm above there. We must include the door frame, the door, this detail work here, and the wall as well. Okay, so in a previous year a question similar to this came up, and it was like these in your book. The only problem is this is a timber frame construction, and both of these are timber frame construction. In the question we're doing here now with the solid concrete cavity wall, with the timber frame, the floor panels, if you remember, were kind of they build up the ground floor panel, they would rest in the floor panel, and then they'll put the top panel up above there. That can't really be done in this case, so we have to kind of fix the joist to the concrete wall in that case, and I'll show you how that's done when we get there. We'll start off by just drawing the wall, and then maybe we'll go to the door. We'll work down through the door first of all. So there usually is plenty of space on the page for this one, so what I'll do is I will draw the wall first of all down through the middle of the page. So we've got scale 1 to 5, we've got 100mm external leaf, 250mm cavity, so quite a big cavity, and 100mm internal leaf. Alright, make sure you leave yourself 400mm of space there so that you can draw in the door. We've got a lintel here above the door and a lintel here above the door, 75mm by 100. Okay, and with such a wide cavity, might be a good idea to put a cavity closer across there. So about 50 millimeters of compressed insulation across there. Alright, the question says that it's a full fill cavity insulation. So we will insulate that full cavity as well, all the way down. Now, details for the door. We're going to draw the door in here first of all. It doesn't mention the sizes of the door frame. It says though it's a high performing insulated wooden door with vertical sheeting on both sides. The door frame is thermally broken and is fitted to a 450mm external concrete block. So we can make up our own sizes for the door frame. The usual size I go for is 150 by 80. Anything in around that, draw yourself a rectangle. You can, within reason, you can go anywhere across that position. So I like to go just at the front of the external wall. If you want to put a little angle design on there, do. For the external door, again, it gives no sizes, so we'll go across about 60 millimeters for that. Cut in about that far, extend that down. And we'll get our rubber on those few bits. So that's the fixed door frame here. It says that that's thermally broken, so include some insulation in that. Use your own sizes for the thermally broken insulation there. This said this is a high performing insulated wooden door, so it'll be a top rail, come down around 100 millimeters for your top rail. Okay, and then you can include insulation inside there. Actually, there's wooden sheeting on both sides as well, so you need to have a sheet on that side and a sheet on that side, and then you need your insulation inside there. We'll see it more clearly on the full solution. Okay, that is the top rail of the door. Okay, now when it comes to doing this joist up above here, we'll say we'll go up one block and we'll start putting the joist somewhere around there. So we'll include a few blocks there. We'll put our joist across here. Again, you can make your judgment there because it doesn't specify exactly where it needs to go. Now, when something like this is being done with a concrete block wall, I just want to show a picture of how it's generally done. What's called joist hangers are used in place here. So these members here are called joist hangers. I'll get a picture there, these, right? And what we need to do is, if we look at this picture here, even though it's a wooden wall there, a length of wood, okay, like a wall plate, is fixed to the wall we're talking about, and these joist hangers are nailed. They're fixed to that wood that we've just put to the wall, and then our joist will fit into those. So I look at a few more of those joist hangers. There's a joist hanger holding this piece of wood onto that. It wraps down underneath also, which you can see from the underside of that picture there. Alright, so we're going to be working something like that. And there's a picture there of a joist hanger. Now there's a concrete wall, and what we're going to do is it's better to fix a piece of wood to the concrete wall rather than trying to fix the joist hanger to the concrete wall. So we're going to put a piece of wood across the concrete wall there and use what's called joist hangers to hold that into place. If you Google joist hangers, there's lots of pictures of those. Alright, so the wall plate we want to fix there, we'll make it a 225 by 50mm piece of wood. That's drilled into the wall with large express nails or hammer fixings, as there can be called. I'm just showing you that. You don't have to draw those in. That's just showing they are fixed in. That's rigidly fixed in. It can't go anywhere from there. Okay. From there, you can just extend on your 225mm joist that's fixed into place there. You can just maybe come down a little like that to show your joist hanger. Shade that in silver. That just represents the joist hanger. It'll go underneath there as well and wrap around the top. Use your own judgment on size there. They come in various shapes and sizes. On the underside of this here, it says in the question there's plasterboard fixed. On the upper side there's a 20mm decking of plywood, and then there's a 25mm hardwood floor put down on top of that. It says a floating floor. The reason it's called the floating floor is because it's not fixed to the actual there. It's just put down and it rests in place. Doesn't exactly float around the place, but it has got a little bit of space for movement with the seasons. All right, and that's pretty much it. Part B of the question, it says show clearly on your drawing best practice to ensure air tightness at the junction of the wall on the first floor. That just basically means make sure that you have your air tightness tape in the corners there. Put some in there, and sometimes even underneath those joists there might be air tightness membrane across there. Okay, we'll look at the full solution. Obviously you have to get your labels into place there as well. We'll look at the full solution here. It's 1:5, so it's quite big. There is the door. I've actually left out a top rail on the door. You can include that if you want. Thermally broken here, insulation in there. That's the cavity closer. There's your lintels. That's the wall. That's the detail work there. So that's the wall plate fixed to the wall. That's your joist hanger. Air tightness tape is mentioned there in part B. And you've got your plywood decking and your wooden floor, 25mm wooden floor on top of that. I forgot to mention as well, just make sure you draw in your external render and your internal plaster as well, and they'll generally come around the underside of the wall there also. So have a look at that and have a go at that question.